Good morning, ladies and gentlemen, and thank you to all for making time to attend our webinar on maintenance readiness today. We are positive that you will get valuable input from the session to apply and implement at your companies or to ask Pragma for assistance. I'm Jan Albert, Sector Executive for Mining at Pragma, and will be hosting the session and will be facilitated by our two Pragma Maintenance Readiness subject matter experts. On our panel, we have Stefan Terblans, Pragma Partner Consultant, and Tiaan van den Berg, Pragma Associate Consultant, who both have extensive experience in different aspects of asset management and specifically maintenance readiness. They both have assisted several clients with their maintenance readiness projects, and due to the challenges associated with these kinds of projects, we decided to host a webinar that will provide some practical guidelines on what to consider before and during a project. Maintenance readiness is an extremely important phase during operational readiness for any greenfields, brownfields, and redfields projects, and applicable to all asset owners in all industries and sectors like mining, manufacturing, infrastructure, and renewable or alternative energy. Did you know that 80% of your asset lifecycle cost incurred during operational phase is determined during the designing phase? Now, during this webinar, our facilitators will take you through practical best practice phases, procedures, master data structures, and methods in order to prepare, establish ownership, and sustainment over life of your assets during these projects. Before I hand over to Stefan and Tiaan, I would like to go through some logistics for the session. Trust that the load shedding in South Africa, for the South Africans who joined, would not influence the participants during the session, but if so, kindly just follow the link on your mobile phone, on Zoom, on your email. However, the recording and the link to the recording will be sent to all the registered attendees around tomorrow at 10 o'clock. You are welcome to ask questions using the Q&A function down at the bottom. I will moderate the questions and post them to the panel during the webinar. You can always post comments in the chat section, which we will respond to. But right, let's go into maintenance readiness. So over to Stefan and Tiaan. Thank you.
Good morning, everybody. My colleague Stefan has some technical problems, so I'll start the presentation, and when he joins, he'll take over his part. We split it in two, but life happens, so he's got some technical issues. He will join soon enough. So the definition and purpose of maintenance readiness. It seems logical that one should have a program like this running on all your projects. It does help to prepare. It's a process of preparing the site's operations and maintenance and supporting team members to manage the new assets. That's sort of the easy part, creating all the information that needs to form part of your maintenance readiness and your project. The second one is the establishing ownership. That's the more difficult one to get right, because you have to get the people involved early on. All the participants, the site team that will take ownership, you need to get them involved early on, so they can take ownership of the assets once they're commissioned. And the only way really to do that is to get them involved as early as possible. Secondly is thirdly is then to sustain it over its life. So maintenance readiness enables the site team to manage the assets for the duration of its operational life. It will benefit the current team and all future teams that will need to maintain and operate the equipment. There is, as was explained by Stefan, by Johan, there's a big value, or a lot of value destroyed during the ramp-up process, as illustrated by this. So, yeah, about 30% of value can be destroyed if the operational readiness and maintenance readiness process is not managed properly. So there will be, it's got to do with the delay of startup, and obviously once commissioned, that's the ownership part, and the spares are not on site, and all those type of aspects that will impact the amount of time it takes to start up. And I think most people that has been involved in the project startup, there's always some niggles. Maintenance readiness and operational readiness, helps to limit the impact and get you up and running quicker. So the ramp up is definitely a bit less than you would have if you don't have any maintenance readiness running.
I'm sorry to interrupt, Tiaan, but Stefan managed to join.
Okay, perfect.
So,
yes, Johan, just want to check if you can hear me.
Yes.
All right. Sorry about that. Despite best intentions, there's always a couple of challenges. So, Tiaan, thanks very much. I think you can just continue to the next slide. Yeah, so I think as Tiaan already mentioned, there's a lot of moving parts to any big project. And what we've done at Pragma is we've created a maintenance readiness framework. Now I realize this slide is very small, with a lot of little blocks, color-coded blocks represented on it. The intention is that we don't pay too much attention to all the details. It's a bit more about the concept that I would just like to explain while we've got this slide up. So first of all, if you see at the top, we've got a dark blue ribbon running from the left to the right, and that's the typical phases that a project goes through. So I think most large companies has got one or other stage gate process where we run from a concept to pre-feasibility, feasibility, build and deliver, commissioning till handover for operations. And all that we've tried to do is we try to represent the typical maintenance readiness activities that needs to happen in each of these project phases. So each little block represents activity. We've color-coded them. Some of them are related to planning. Some of them are related to people. The gray ones related to systems. Me and Tiaan is going to talk a bit and focus a bit today more on the reddish ones. That's very much maintenance and reliability related. But I think just as a start, please take note that maintenance readiness activities, there's certain activities that needs to happen in each of these stages. And Tiaan, if you just go to the next one. How we're going to handle the rest of this presentation is I'm going to talk a little bit about what needs to happen before final design. You can see there I've circled the final design on the maintenance readiness framework. If you think back of the definition that we put up in the beginning of this presentation, I think a lot of people relate to doing preparation work for the end user. Now, that preparation work is quite often a lot of the stuff we can do after final design. That's the stuff we can do during the execution phase. But very importantly, if we would like to ensure that the project is sustainable in the long run, if we want to ensure that this project, the thing we bought, the thing we've designed and commissioned, delivers sustainable results for many years, we need to get involved before the final design. We need to influence the final design. So I think as Johan and Tiaan mentioned, so important that we don't only see maintenance readiness as We're starting with building the plant and commissioning, and then see what we can do from a preparation point of view. Yes, that's important. If we really would like to ensure sustainable plant or equipment, we actually need to get involved before we finalize the design. So I'm going to focus on 3 things that needs to happen before we finalize the design, and then I'll hand over to Tiaan to talk about the typical things we do in support of preparation. And just again, to remind you about this importance of getting involved before the design is fixed. I think Johan mentioned this. It's an old graph that appears in many of our engineering textbooks. However, we often tend to sort of ignore it. If we just forget about the red line for a moment, and if we just focus on the greenish one, yes, 80% of the cost of an asset we spend over its operational life. But 80% of that cost is determined actually during design and commissioning. And that's actually a bit, I think, scary. We often employ reliability engineers during the operational phase to try and improve asset performance or to try and improve reliability. But what this really says is they've only got about 20% levers that they can pull in the operational phase. 80%, of the reliability is already fixed during the design. So important that, yes, defect elimination and root cause analysis and stuff is important during operations, but we'll have to sort of wake up and realize that, a lot of that effort actually needs to already be applied in the design and commissioning stage. Right, Tiaan? Yeah, so just the 3 things I would like to sort of highlight while we're still in pre-feasibility and in feasibility already. The first one is just about having a maintenance readiness plan and budget. So Tiaan, if you tick over. So some people often think, or ask myself and say, Stefan, isn't this too early? We're only in pre-feasibility. We're still evaluating 2 or 3 alternatives. We haven't even pegged it down as a final design. Can we already now start talking about maintenance readiness? And all I would like to highlight is that in feasibility, as you can see on this slide, there's many maintenance readiness activities that we need to complete. And we need to get money and resources to complete those activities in feasibility. To get the money and resources, we need to enter feasibility with a realistic maintenance readiness plan and budget. Otherwise, we're not going to get it. So just would like to highlight that already at the end of pre-feasibility, we need to come up with, what are all the maintenance readiness activities we would like to do during feasibility, everything we've circled there in the dotted line, and then put a bit of a price and resource effort down to say, this is what we expect to do, and this is the amount of money and resources that needs to go into the bigger operational readiness budget. If you're in feasibility and you then ask for the money, you're simply not going to get it. All right. Then the second part, or what we believe is very important, leading up to feasibility, is at an early point, also here towards the end of pre-feasibility, is to start pegging down what we call the reliability specification for the specific project. You can see there we've sort of circled 3 reddish blocks about a maintenance strategy, a reliability specification, and asset strategies. And in all those things are important that we consider that going over into feasibility. So Tiaan, if you just page over. The first is just to recognize existing asset strategies. Now, yeah, I just need to be clear. This asset strategies in our Pragma context, this is not maintenance tactics or how do we maintain a specific asset. If we talk about asset strategies, this is a high level asset management plan for a specific asset or asset type. The example I've just listed here is, let's say in a mining plant application, a double dry screen, where, there's a high level plan of, this is how we think about double dry screens. This is high level, how we're going to maintain it. This is our overall and our replacement strategy. And if we're going to replace it, what alternatives are we looking at the moment from a technology point of view? So a lot of companies has got for their key or their critical assets or their asset classes, they've got some existing asset strategies. And these are very important that we provide this to the EPCM companies, that they're aware of. This is what we believe, and this is where we're going. And please consider this in your designs. We see too often that EPCM companies just come up with their own things, and meanwhile, we've already standardized on a specific design, or we've got a very clear technology strategy that we would like to pursue. And yeah, the EPCM companies or the designers are simply not aware of that. So the first part of already in pre-feasibility is, please be sure to share your existing asset strategies or try and incorporate that into the design. That's going to make stuff a lot easier for us, related to the topics that Tian will talk about. The second very important aspect is this whole concept of a reliability specification. Now, it sounds very fancy, but it's actually very simple. It's all about, what is the requirements of the specific asset. You can see there in the greenish block, we've just listed a couple of questions, but it's amazing how we get involved in the build and deliver phase. And when we ask these questions, it hasn't been pegged down. Simple question like, we've designed a treatment plant. How often can we get access to do maintenance? Can we have 12 hours every week? Can we have 12 hours every 2 weeks? What's the availability specification? What's the reliability of the key 5 components of this plant? Those simple questions, if you don't peg them down, then a lot of the other stuff we're going to do, we're really going to struggle. We cannot develop maintenance tactics because we don't know what's the expectation. So just would like to reiterate the importance of, at a very early stage in the project, understand the overall requirements and translate that into maintenance and reliability requirements that we can work with. The background, you'll see there's a very simple reliability block diagram. You don't need to get carried away with fancy simulations, but we still got problems today with people that doesn't understand the implications of a lot of assets in series, and the overall effect of that on availability and reliability. If we want to influence the design, we need to do some simple calculations where we at least can inform the design team to say, listen, you're not going to be able to run with one of these assets here in series. Rather go for 3 smaller ones in parallel, because that's the only way that we're going to get the reliability and the availability that we're looking for. So at a very early stage, we need to peg down the reliability specifications that we expect. Right, that was a couple of notes related to pre-feasibility. When we get to feasibility, we expect that we've sort of eliminated all the alternatives, and we've got now one alternative or one design that we run with, and we need to move towards that final design. And you can see there's sort of 3 red activities listed. The one is lifecycle costing that I'll speak about just now, tactics development plan that Tian will handle. And then the last one that I want to start with is just about reliability and maintainability analysis. Okay, let's start with that one. And there's a lot of abbreviations and concepts floating around. I don't really care what you want to call it. Some people refer to these review sessions as a RAM session or RAMs or Rambo or Rambos sessions. Ultimately, all of these things refer to reviewing the design in a lot of attention, in a lot of detail, from the perspective of reliability, availability, accessibility, maintainability, buildability, operability, safety, security. So all those things I've listed, that's where the RAM and the RAMs and the Rambo and all of those abbreviations come from. It's focused review sessions where we systematically work through the design with the EPCM company or with the designer or with the supplier to make sure this thing is going to work. It's so important, but so often neglected. And this you can't leave to the design or EPCM company. This is where you need your best artisans, your best engineers that's got the most experience to participate, to have a look and say, how are we going to get in there? How heavy is that thing? Can we get a crane in there? We need a crawl beam. There's not enough access. Let's build another platform. That conveyor belt, there's no ways that there's enough space that we can actually change the belt. Where we will be able to store this significant component. All of those questions, we need to systematically work through by looking at a fairly detailed design. So just very quickly, you can do it in one shot. Quite often we need to break it down into smaller components, but it's a series of review sessions with experienced end users to influence the final design. So very important, you need to do it before the design is fixed. Otherwise, it's fairly pointless if you can't influence the final design. This review sessions, call it RAM, RAMs, Rambo sessions, are also the ideal opportunity to finalize the procurement packages that needs to be sent out to suppliers and vendors. What you see here on the screen on the right hand side is just the outcomes of a RAM session we conducted a while ago. This was in a diamond mining application. It was a new plant that was built. And you can just see there, I just took a snapshot from the final report related to bins, chutes, and diverters. But as you work through these review sessions, you make specific notes about the assets and the asset types. And these notes need to make their way into the procurement packages that's going to be sent out. This is where you want to drive standardization and detailed specifications that the suppliers and the vendors need to quote you on. So very important. And you can see the level of details there that you write in there exactly what you're looking for. That example listed a couple of technical aspects, but I would like to further expand this concept of influencing the procurement packages with some other notes as well. Tian is going to tell you the stories of how they struggle to get information out of the suppliers and the OEMs. So going back to this procurement cycle and the specifications, it's so important that we write in there exactly what we're looking for, not only from a technical perspective, but also from a manual perspective. Are we looking for 3 copies, hard copies of the manuals, a soft copy and updates for the next 3 years? Maybe we're looking for the ebook, and we want to have access to that ebook for the next 5 years. Technical training. You'll see there at the bottom, warranties and performance guarantees. That's a topic we can probably speak a whole day on, related to what do you specify related to warranties and performance guarantees. Do you want to pay for it? Some people think it's for free. It's never for free. You pay for it. But you need to think about what are you looking for. So think a bit wider than just simply adding technical specifications to the procurement packages. This is your ideal opportunity to specify all the other peripheral things from manuals. You can even specify you would like the maintenance recommendations based on an FMEA. But if you're not going to do it here and you ask for it afterwards, you ask for it after it's been awarded to OEM, you're going to struggle to get anything out of them. Okay, and then just a quick reference also, lastly, from my side, about lifecycle costing. Quite often if we get stuck just there prior to the final design in, we need to make a choice between this model or that model or this brand or that brand, we often need to do a detailed lifecycle costing analysis. Just the example of a truck. And yes, you never have all the information, and the suppliers and OEM often provide you with very figures that looks very good. But we need to do the best with what we've got. And once again, we want to do this before the final design, that we can make an informed decision. Then, once we're operational, we ideally need to track ourselves against this model that we've developed and see, yeah, we estimated that, we're going to run at let's say $1 per ton. How are we doing year on year against that original life cycle costing evaluation that was done? So also, I see quite often people do this LCC little calculations once the design is fixed. It's actually too late. We should do this in the beginning to influence our equipment choices. But then, yes, measure ourselves in the operational phase against this to see how effective we are. All right, so that was a very quick look at 3 things that we should do or should focus on before we fix the final design. Once the design is fixed and the people start to build, yes, then it's over to all the other preparation work that we need to do to make sure the end users can start that asset or that plant successfully after commissioning. And I'll give you over to Tiaan to take you a bit further.
Thanks, Stefan. I think you highlighted again, as we said, the earlier you start, I think the more value you can get from maintenance readiness. But a lot of the sites or projects do get that right. They do get involved early in this. They do get people involved, knowledgeable people involved early. We get involved from Pragma side. We've got involved more after the final design. And if you can think back to that quite busy framework, there's a lot more red blocks there. So this is where a lot of the effort goes into. So I'm going to focus on just a few of those blocks and a few of those processes in the framework, which is the asset register, how important it is, the maintenance tactics development, including that criticality, the spare parts, and obviously the people and competencies, the people who needs to maintain this, very important. So the asset register, it's not only beneficial for the it's not only applicable to maintenance reliability. Obviously, you need this to go into the information to go into your EAMS. You'll use it for all kinds of, all other departments will use it as well. One can only really get the information to the right level or to a stable level after the final design. But obviously, the earlier you start, the better. So I've just noted a few activities that's quite important and some tips regarding that. Highlighted the ones that I think is where we found that we need to spend more time on. So the asset register, functional location structure, whatever you want to call it, is the golden thread, and because you're going to use that to build all your other plans and to conduct your criticality, even your RAM sessions will require some sort of asset register to build this around. So getting your asset register ready, even during pre-feasibility B or pre-feasibility, is a good idea, because you can see you're going to use it for all kinds of activities, and it's especially important when you get to the build and deliver side of the project. Remember that the asset register is a structure that will be managed on an ongoing basis. So the more information you get, you have to adjust it, you have to maintain it through the whole project, but get going early. Also important, and Stefan mentioned it as well, you need to inform the EPCM of your asset specifications or your maintenance strategies, your asset strategies. You also need to inform them about your EAMS standards, your numbering format, what level do you build this on, so that when we get to the P&ID numbering, the equipment tags, it's actually got a big impact on safety as well. We don't want P&ID numbering to differ from our equipment tags, and you get health and safety risk. People can lock out or isolate the wrong asset, and that's a big problem. So really get that started early and get it to a correct level so we can maintain it through the whole process. Moving forward to the asset tactics development, I mean, it's a large block, probably the largest in that framework, and there's a lot of subjects that form part of that one block. You can even see, I mean, it feeds into so many. If you think about it in the systems way of thinking, the asset tactics, it feeds into so many other deliverables and other processes that, I mean, it's not we can spend again a lot of time discussing everything that needs to happen there, but it is a critical block, and it spans quite a long period of time. But we are still limited in the project as to how much time we can spend on this. But very important. Most of you has probably been if you're from an engineering background, you've been involved in asset tactics development sessions or developing tactics or improving on tactics. So the same principles apply, the same best practices apply, but you might have to tweak it slightly, because now you're not only, you're on a resource constrained area, it's a time constrained area. So it's not just, you need to get everything done before the project commission. So the same applies, but it's extremely important to add your process specialist during your criticality analysis. They will be able to identify the impact of breakdowns better than anybody else. Most of them has been involved in the design process and the RAM processes you've done before. So they will be able to help you identify that impact. You still have to do the criticality analysis to focus your effort on the assets that are more critical, the ones that will have the biggest impact when there's a breakdown. So you won't treat all assets the same. You'll probably do an FMEA or an FMEA for critical assets, where the lower criticality ones, you'll use what's available, or you use OEM recommendations only. Of course, we need to identify critical spares. We need to motivate why we need to keep these spares. So this is also part of critical spares identification. Underestimating the manpower or the effort it will take to develop tactics is a bit of a pitfall. Most of the time, the people who are involved in the development of tactics is also the people that needs to run the current plant. So if it's a greenfield project, maybe you don't have the same problem. But brownfield projects, the people you want to involve in developing tactics, also the people that need to run the plant. So usually a bit constrained with your resources there as well. We have to remember that the goal of asset tactics development is not in maintenance, from a maintenance readiness point of view, it's not necessarily to get it perfect, but you need to get it to such a level where it's a good foundation for somebody else to improve on. There's just too many uncertainties and unknowns, specifically when it's new equipment. So with the time constraint, using some tactics of similar equipment just to set a nice base is always a good idea. You can save a lot of time by doing that. Of course, OEM manuals, I had to highlight it or show it, it's not always detailed enough, and it's almost never detailed enough when it comes to maintenance. But you do need that to create your precision maintenance, to get your torque settings, your loop, you need lubrication. You need to use all that details you need to get from the OEM. So a big part of that. Of course, right in the bottom, we have the long-term planning, and that's your reality check. So once you've created all your tactics and your work packages, you'll be able to see, do we have enough manpower to maintain this? You had to appoint a team, or at least start budgeting for a team before you did the tactics. So this is a good idea to just do that long-term planning and see if you've got got yourself covered with regards to your staffing, your resource requirements. The spare parts, I know we said we're going to focus more on the red blocks, but there's a whole batch of yellow blocks as well, which has to do with your spares. So you have to get your spares, you have to involve your supply chain department, and in bigger companies, there's quite a process of getting your spares committed or into stock. You commit a lot of capital, so it takes a bit of motivation to get that spares into stock. But you usually have two sources of spares information. That's your asset tactics. So when you develop asset tactics, you identify spares you need to keep because of stuff you need to replace or repair. And of course, your OEM provides recommended spares. It would say, please, those recommend keeping the following. But all of that you only get once you've done your final design, and also once you've started tactics development. That's a whole process. So you can't always get everything in place before commissioning, or it's difficult to get it in place before commissioning. But I've highlighted there at the bottom. So procurement of long lead time items, you need to get started early. I mean, with COVID, it even became worse. There's a big supply chain issue. A lot of the spare parts and a lot of equipment is manufactured in China. They went on lockdown. Suddenly something that would have been available in 3 months is now 6 months, sometimes even a year. So you can't really wait until you've developed all your tactics, but you have to make sure that the long lead time items you get started on early. I also want to highlight the fact that you need to code all your spares, even the ones you're going to not keep in stock. You want to eliminate that uncoded spend, and if you do it now, you get it ready. It just makes it so much easier for the team that takes ownership of the plant to buy spares, because you already added that information to the bill of material. and it will, I mean, it helps them a lot to order and get it into stock. You need to think of spare parts that will be supplied as part of the project. There's a lot of time you need commissioning spares, and that you need to get sorted out, obviously, before commissioning. Otherwise, it doesn't add the value you want it to. Again, you need to use your assets register or your function location structure as a base for this, so you can link your spares to the bill of materials, and it just makes it so much easier. I also say don't underestimate the manpower required. This is a whole process of codification of spares, as well as motivating to keep it in stock, ordering it. You're not necessarily, engineering guys are not necessarily ordering it. It's done by the project team or by the supply chain team. So a lot of effort and a lot of time required to get your spares in place before, well, get the timing of it correct. Of course, we need the people, we need the staff, we need all the maintenance, engineering personnel, obviously operational personnel as well. You need to get your agreements in place. Your contractors need to get onboarded and inducted onto the site. So a lot of activities dependent on getting your people trained up to the correct level before you do commissioning. So highlighted that there, also highlighted the long-term planning process, obviously, just to check if you've got the correct staffing complement going. And yeah, Stefan mentioned it, you have to get, you need to write into your proposals or into your procurement packages that people need to get trained. You need to budget for that. New equipment specifically, you need to, the OEM or the vendor needs to probably get your people trained up to be able to maintain it. We need to make sure that we've done the size and capability of the team quite early on. We need to review that as well. Be careful of generic benchmarks. I mean, the operational context might be different. Also very important, getting your operational readiness team to transition into your site team. So when you appoint somebody to the maintenance readiness team, whether it's an internal or a new internal resource, a new recruit, it should be the person that will eventually take ownership of the plant as well. There's a whole, there's a slide I'll show that's coming up, which will look familiar, and you need to get them involved early on and transition them into the new team. Also, again, outsource competence, or the outsource part of your maintenance team, you need to get them onboarded and ready. And in some cases, they need permits there. I think Stefan, he knows the diamond mining industry a bit better, but I mean, there's restricted areas where you need to get access. All of that you need to get into place and early on, so that you don't surprise your vendor or your contracting company. Don't get a surprise and then don't want to do it. So get that in early. And yeah, I mean, if you look at all of this, it looks logical, but it's a lot of balls in the air, a lot of activities that you want to happen. Usually think of it only when you require it. So you need to think a bit proactively and get it in place. And anything you do now definitely will benefit you during the operational phase of the project. So here's the slide I was talking about the early involvement. So in the beginning, I mentioned you need to have, you need ownership. You need the new team to get to take ownership of the plant. And I mean, there's the 5 stages of grief almost. If you don't do your operational readiness or maintenance readiness tasks, if it's an over the wall type of situation, the new site team, you're gonna have that drop in you're gonna destroy value during your ramp up. as we said in the beginning. So you're going to get that once it's handed over, the guy's going to fight. He's going to say, why did you use this motor? We always use that type of motor. Why is there not 2 sets of pumps? Why is there not a spare for this? That type of thing. So there's going to be anger. And at one stage, they're going to, accept it. But that's going to be, you're going to destroy a lot of value in that process. So that's on the left. On the right, you'll see if you get them involved early and just a little bit, and a few people and just some selected people get involved early, that transitioning from during the handover, they just take the ownership and run with it. And that was the main motivation, that value destroyed during handover. It just makes sense. It just makes sense to do maintenance readiness and get those people involved early, let them take ownership, and you save money and you get that asset of yours productive much sooner than you usually did. And then, I don't know if you asked this already or somebody asked this, but who's the right person to drive this process on your side or at the client side? And that would be your reliability engineer. This is a role, sort of a summary of the role of a reliability engineer, and usually they're focused on defect eliminations. That's after the fact. But if you get them involved, in the RAM sessions and they run with that, you get them involved in maintenance tactics development and in the lifecycle costing, I'm sure you relieve the amount of time that's required of them to conduct defect elimination. And they can actually add a lot of value during the maintenance readiness part of the project. So that would be the best guy or the best person to run with or to involve as a team member early on in the process, so that they can obviously at least maybe reduce their workload during the operational phase of the project and of the plant. So Stefan, back to you just to close it out for us.
Yeah, thanks, Tiaan. I think we've presented a maintenance readiness framework. It's not that easy to read on the slides, but if you visit our website, there's actually a link where you can download a copy of that maintenance readiness framework. The benefit of a framework like that is it just prompts your mind related to what are the things we need to consider in each of these phases. And I think that in itself already adds a lot of value. Just Stefan? In summary, yes.
Sorry, but on the questions and answer box, if you open it, there's 3 questions listed, 1 by Boyke and 2 by Andries. Would you like me to read it out for you, or do you have it open in front of you?
Johan, you can read it out, but let me just quickly just run through this couple of notes in summary, and then just please read them out to me. Good. So I think we already, and I think a couple of times alluded to the fact that yes, we spend 80% of the life cycle cost of an asset in operations, but 80% of that cost is actually already fixed or determined in the design phase. So let's just keep that in mind. Tiaan mentioned that there's a lot of value destroyed in the transition from a project to the operations. And maintenance and operational readiness can play a leading role into limit, that value destruction. One thing we didn't explicitly talk about is this inherent conflict between projects and operations, and I maybe just would like to highlight that. It's something that's never going to go away. If you leave a plant to be designed by maintenance guys, they're probably going to specify gold-plated everything. The plant is going to become so expensive, it's never going to get past feasibility. So in that, there's always a bit of a conflict between projects and operations. Yes, projects is going to try and deliver everything within a certain budget. but we just need to be aware of this conflict, and we need to manage it. We cannot ignore it. It's always going to be a bit of a give and take during those final design stages related to getting the final design right and appropriate for your business. Yeah, just some last notes there. Tian mentioned that a reliability engineer can play an important role in facilitating many of this maintenance readiness work. Reliability engineer can't do everything him or herself, but definitely can play a leading facilitation role. We often get asked, who should do all of this stuff? There's no magical answer. What we normally do is we look at this maintenance readiness framework at an early point. We sit down with the projects and the end users, and we agree who's going to do what. So that good, simple communication related to, here's all the activities that needs to happen. Let's just already agree in the project phase, who's going to do tactics, who's going to sort out the spares, to a large extent already add a lot of value in getting the stuff done. And then maybe just the last one, don't underestimate the effort. We often get asked to help with tactics or spares, and the people tell us, listen, in 2 months' time, the project needs to go live. You quickly need to come and help with the tactics and the spares. In a let's say a typical surface plant brownfield project, that task can take a team of 4 people nearly 2 years to complete, if you want to do it properly. So yeah, always just be mindful of the effort to sort out the function location structure, the tactics, the spares. The end users, the operational team, will never have the time to do it. So yeah, we need to come up with a good plan how we can actually do it as part of the project. Right, so that was just a couple of summary notes. Johan, if you maybe want to just pose some of those questions.
Yes, so from Boyke, the session highlights the importance of the plan design phase of the asset lifecycle. So in his experience is that process of plant owners and executives who specify what they want often fail to consider long-term significance of decision-making at this stage. So as a third party, how do you influence asset owners to consider and ensure that RAM's review sessions are carefully conducted and applied before actual equipment design?
Yeah, so it's not an easy and simple thing. So I think what we normally try and do is, as part of this maintenance readiness framework of ours, between the various stages of a project, there's normally a stage gate review activity that happens. And we try and, get involved in that stage gate review sessions, where we normally, first of all, highlight the need for a specific RAM session or specific simulation or reliability block diagram session that needs to be conducted. And as I said, if you don't do it before the phase start, quite often, if you're in that specific project phase, you're simply not going to get the resources and the money to do it. So what's normally quite effective is, let's say at the end of pre-feasibility, you try and force in something like a simple and a fairly inexpensive activity like a reliability block diagram. And by doing that quick exercise, it very quickly highlights significant issues that at least is going to make top management aware of, oh, we need to pay attention to this. Here's certain areas that needs further investigation. So if we just talk like this, we're never going to convince somebody. But if we can do a simple activity like a reliability block diagram, that normally, the results coming from that normally speaks for itself. It highlights some initial issues, and then that at least, create the platform to sit down with management and say, in this area, in this area, in this area, listen, we need to pay more attention up front.
Thank you, Stefan. Okay, then from Andries, these strategies comes obviously at a cost. Teams need it upfront to do the work, etc. So potential claimed future value saving, but in brackets, by not destroying value is up to 30%. I don't know if it was a comment, but
yeah, okay, maybe just people always sometimes ask us, so quantify the value of this maintenance readiness activities, and then I normally just firstly tell them, you anyway going to spend the money. So if you don't do the tactics during the project, somebody's going to do it, as Tian said, as part of the operational phase, and it's probably going to be ineffective, and it's going to be a bit of a mess because that person has also got a normal day job. So the first statement is, the time it takes to do maintenance readiness, that you anyway going to spend, maybe just later on and more ineffectively. The benefit is all about ensuring that we limit downtime, and all the effort that goes into the spares, identifying the correct spares, making sure they're there, that's all there to try and eliminate future downtime. So yeah, always difficult to exactly quantify the benefit, but I can say with a lot of surety that the money spent on resources to do maintenance readiness, that's in itself, you anyway would have spent just at a later stage. So that's for me already a break even. Okay. Any additional things we do just adds value to the reliability and the downtime reduction of the plant.
And Stefan, we've discussed this many times as well, that it's the reduction in risk, right? If there's a critical spare that you don't have in stock, you might not run your plant for a while. So, I mean, people rarely get credit for problems they avoided. You get credit for fixing a problem, but this is actually trying to avoid problems. So difficult to put a rand and cent to it, but hopefully somebody else can show that through experience there's been something like this. If we prevent it, it's much better.
Yes. And but what is the typical net present value percentage increase one can expect?
Yeah, so Johan, unfortunately it's not a simple answer. It depends on if you buy a HME truck, if you do a greenfield or brownfield project, how much influence do you have in the design? I think the best reference we got is this, that study that was done by Deloitte that we referenced, that says we lose around about 30% of value due to poor maintenance readiness. So that's normally the one we quote. It will be great for us to, I think, do some more analysis as we continue to maybe come up with our own figure. But at this point in time, let's reference the Deloitte study that was done about 2-3 years ago. Yes, it was specifically in the mining industry. Some other industries like the manufacturing industry might be slightly less, but let's play with that 30% net present value saving as a result of good maintenance readiness.
Thank you, Stefan. And then from a Michael, just in the chat box. So as the OEM and supplier of torque tools for major shuts, we put a lot of emphasis on safety and training. Often equipment is used by untrained personnel due to poor planning, and basic tool training is overlooked. And that's definitely an area that's addressed around roles, responsibilities, and learning pathways on the training side. But maybe if you could give some input specifically on the massive impact on training to operate and maintain these specific new equipment.
Yeah, so maybe I can go first, and I think Tian already touched on that. Already in feasibility, one needs to make a bit of a call about, are you going to do the maintenance yourself or are you going to outsource it? So there's already a very strategic decision. You cannot go into the execution phase and then still wonder about that. And that decision has got a couple of implications. If you decide you're going to give this out as a mark contract or another company to maintain, then your focus shifts more towards SLAs, contractor management, making sure you've got the proper contracts and control mechanisms in place. If you're going to use your own people, then the focus moves much more to how do we train them, how do we ensure they're competent. But it's a very important part. I think the biggest challenge is it's just simply left too late. So as the comment there about just the use of special tools, the use of specific equipment, very important. And we normally try and address it in the training and development plans. The challenge we've got is when people start to consider these things. It's normally too late, and then we run into problems. So it's sort of all coming back to, you cannot start maintenance readiness, when you go into the execution stage. There's so many things that already actually needs to start happening already in pre-feasibility and especially in feasibility. But Tiaan, I don't know if you want to just add to that comment about training and skills development.
No, not really. I can add to that, not really much. But during our tactics development, and again, you said it might be a bit too late, we do identify as much detail as we can from the OEM manuals, which would include the special tools required and those type of things. But I know one don't want to start too late, but I would say anything you can do to reduce that 30% value that you destroy, even if you start a bit late, anything you can do will definitely add value. I keep on saying it. Maintenance readiness to me is just a logical decision. I know you need to prove or provide some motivation to the financial people specifically, but it just makes logic sense to me.
Thank you. From the participants, any more questions? As we've been through our 1 hour.
Johan, maybe just on the chat box, there's a mention from Michael and from Tinus.
Yeah, so Michael.
So you've done Michael, but Tinus is new. Thank you.
So Tinus asked, one of the issues that we face frequently is to make project payback low. The group that then pitched the project tried to reduce the investment by phasing the cost of maintenance. We will deal with it later. Issue occurs.
Yeah, and it's I just visited the site yesterday, and that's got significant challenges in sort of deferred maintenance. So I think the big challenge is just your time frame that you look at. If you look at a project and you look at the only next 3 years, you can very cleverly sort of delay a lot of maintenance to make this thing look good in a 3-year period. But I think unfortunately, we need to consider a slightly longer period, a slightly longer window to look at this specific project. So that's normally what we do. If we see a specific client and a specific project team is pitching something and they're only looking at the next year or two, we'll have to remind them to say certain structural things is only going to happen in 10 years. So let's just stretch this picture a bit further and create this 10-year picture to give you a much more, a bit more of a reality of what's going to play out. And yes, you can maybe decide you don't want to do this in year 2, but then you'll have to do it in year 3. Otherwise, in year 4, this thing is going to fall apart. So my only recommendation is if we look too short, then we normally run into issues with improper maintenance decisions. We unfortunately sometimes will have to do a bit of clever calculations and say, let's just take a 10-year view. And that way, hopefully management will realize, yeah, we can postpone or defer it once or twice, but in this bigger scheme of things, we'll have to do it. The sooner we do it, the better.
Yeah, I think you did give good advice, Stefan, to say get that reliability block model in there, as a starting point, at least the base model. And if you use the simulation part, which adds a bit more time, but you have to specify a time frame. And I think as soon as you do that, maybe the mindset will change to say, okay, we need to look a bit further into the future.
Okay, I think we've answered all the questions. Stefan, maybe, and Tiaan, maybe one thing from our side. We did mention the whole thing about projects and handing over to operations. And that's specifically, people and new people. Isn't it a good option? It doesn't matter if it's brownfields, greenfields, redfields, to already have an established focus from a reliability engineering team or individuals, as well as maintenance planning guys, from the design stage, where you start to actually build from asset register uptake, from the QS list, going over into the tactics development, and then as an handover from projects to operations, they're already part of the operational team, and they can continue with their specific roles because now they know they build it. Maybe just a comment on that.
Yeah, Johan, so for greenfield projects, that's normally the preferred option, where the people that's going to do the maintenance readiness work, you would like to appoint early. You can't appoint them in feasibility because the final decision hasn't been made about going ahead. But you want to appoint them at the beginning of execution, and then you use them, as you said, to develop the functional structure, to develop the tactics, to develop the spares. And then they're there from the start, and they're part of the commissioning, and they continue. And that's normally, and I would say for the bigger greenfields projects, that quite often happens. Our bigger challenge are normally with the brownfield projects and some of the smaller stay-in-business capital projects, where people think that, but we've already got an existing maintenance department, we've already got an existing planning office, so that they can just pick up the stuff. And that's where we quite often see the biggest issue, where you should think, but that planning office was established to handle business as usual. Now they need to suddenly handle a big brownfield projects, and they simply won't have the capacity. So there you are, I think, and also the smaller SIB projects, there you need to say, well, we're going to need another maintenance planner. Let's appoint him now as part of the project, and then he becomes the operational maintenance planner at the end of the day. So what we've seen, greenfield projects, normally people think, as you said, but unfortunately, the brownfields and the smaller projects, yeah, they just think there's already existing resources, let's just use them on the project. And there we need to think cleverly. Us as a service provider, how can we provide assistance for the end users?
Thank you. Okay, so I think all the questions are answered. We've run a little bit over, but good conversation, good questions. Thank you for all the attendees. Really hope you took some valuable inputs from us. If you have any questions, make contact with me, and I will put you in contact with our specialist, with Stefan and Tiaan. But then thank you very much for the panel, and for Lisa and Jolene and Karen, always at the background, for setting the webinar up. Thank you for your time, and we're closing the webinar now. Have a wonderful day, everyone. Goodbye.